All right, we'll get started. Hi, everyone, and welcome to NZGDC21. First of all, thank you for picking me to be your first presentation of the conference. I hope I do you proud. My name is David Delgado, and I'm a software engineer. I've been working in the games industry for about 5 years now. Before I get started, I got told that it's really important to build rapport with your audience before you start. So I thought, okay, let's talk about some things that we have in common. So I thought, like, okay, game conference, games, right? So my first game console was a PlayStation 1. Any PlayStation 1 players in the room? Yeah, nice. I used to play a lot of Crash Bandicoot, right? To this day, don't know what a Bandicoot is, but hey, no worries. Also played those like Disney games like Hercules and Tarzan. Man, those games were hard though, eh? You got like 3 lives, and if you die, that's it, back to the start. Like, even Dark Souls doesn't compare to that, eh? What else? RuneScape. I played a lot of RuneScape in my day. I actually learned a lot from RuneScape. Like, this is real funny. We were at a park like with my parents. My mom's like, oh, that's such a beautiful tree. And I was like, that's a willow, Mum? Yep. And I knew that because I'd been cutting down so many trees, and willows grow by water. And I was like, man, RuneScape's just, it's better than school. Far out. How about something non-game related? Let's see. I'm trying to find where I can buy some like new black jeans, but like I have this problem where every time I buy black jeans, they come like pre-magnetized to attract all sorts of like dust and pet hair and fluff. And every time I wear them, I look like I'm wearing a sweater on my legs. So I don't know like how people do it. There's some secret out there, or like people just carry a lint roller in their back pocket. Yeah, I don't know. But hey, that's some fun facts there. And hopefully now we've broken that wall. Now we've got a bit of a connection going. You know, I'm human. You know, we can relate. You can talk to me. We're chilling. So yeah, I have the absolute pleasure to work for game development studio Mytona. For those of you who don't know us, that's fair enough. We're quite new here in New Zealand, though we are an international studio. And our origins date back to 2012 in the coldest city in the world. And I mean coldest. I mean minus 60 degrees Celsius in winter. And it all started, I'll just tell you a little bit about who we are before we kick on. It all started with these 2 gentlemen right here. Twin brothers Alexei and Afanasy Ushnitsky, and they're from Yakutsk. And yeah, they came across an article one day where they were like, they saw that people were making games, and they thought, well, if someone's doing it, then by all means, we can too. And since then, our company has grown from the twins to this last year, over 1,000 people. Mytona isn't confined to any particular part of the world. We have a few studios in Russia, one in Singapore, and the latest one here in Auckland, which opened about 2.5 years ago. But as you can see, we've got people working for us all around the globe, all coming together for, with one passion, which is to make great games. Our office is in the heart of Takapuna. We've got some really nice views, really nice work culture, and our office reflects that. So we got gaming consoles, we got massage chairs. It's hardly work, you know what I mean? Like, it's great. It's great. And but it's not just our Auckland office. All around the world, we've got this sense of that you come into work every day and you're in an environment which is, yeah, it's productive, but it's also fun, exciting, and yeah, it makes it really cool to come to work every day. Our games. We have a big portfolio of games, but 2 of our most popular ones are the ones I'll talk about today. And one of them is Seeker's Notes, which is Mytona's hidden object title, where as many in the genre, you're going from scene to scene trying to find the hidden objects and within the time limit, but it's also packed with some other adventures like match 3 and puzzles and so on. Our other very hot title, excuse the pun, is Cooking Diary. And in Cooking Diary, you're basically in the shoes of a master chef, where you are preparing, making, and serving orders to your customers. So if you like multitasking, this is basically the game for you. And basically, as you finish one restaurant, you work to another one. So it's always changing. So today you could be working at a sushi restaurant. Tomorrow you could be a master cake baker, and so on. But just because we specialize in mobile games doesn't mean we don't diversify. Our latest venture is to team up with development team Fantastic to publish The Day Before, which is coming soon. You can wishlist this on Steam right now. It's a post-apocalyptic survival thriller PvP, PvE. That's a lot of adjectives to say. I'm describing this like crazy. But yeah, think of it as like The Division combined with like The Last of Us sort of vibes, right? So yeah, this is coming soon. For time's sake, I won't show you the trailer, but yeah, come talk to us after if you want to know more about that. But yeah, let's get started, guys. So the idea of try before you buy. It's not something that we're new to, right? And yet it has revolutionized the way we as consumers interact with the products and the services that we're around, right? We only need to have a quick look, a quick scroll through our phones or our desktops to see a whole bunch of services and companies who provide this sort of, or who embrace this sort of mindset. So if you think things like Audible, Netflix, Spotify, Disney Plus, they're all really happy to give you a month free subscription before you actually invest in the product. But it's not just digital media and digital products either. Think about when you go to the gym, you get a free trial, right? Or when you buy a car, there's always the chance to give it a test drive, right? So as consumers, we love to be certain about something before we commit to it, right? It gives us that security and that confidence that we need to put our money into it, right? Now, what if we could take this exact same concept and apply it to our game development workflows in order to make the development process more effective and more cost efficient? This is the idea that rapid prototyping is built on, right? And it's all about saving your team time, saving your team resources or money, building your product effectively and efficiently, and if done well, can even, excuse the fonts again, just did this before, if done well, can even catalyze and encourage team collaboration and knowledge sharing, right? Basically, rapid prototyping allows you to focus the majority of your time on the ideas that will truly bring tangible value to your end product, right? And so, but before we dive in to what that looks like, let's revisit what our day-to-day workflow process would be if we were trying to add a feature into our game, for example, right? Well, as many of us know, it all starts by identifying a need. So our game needs something. Maybe it needs a bit more excitement, a bit more randomness, whatever it is, the need brings about change. From there, our design team will come along and they'll brainstorm some solutions, right? What can we do? How can we fix this? They'll think of a hypothesis, right? So we think this is gonna solve this issue by doing this, and they'll write a spec document. Great. From there, we usually go and all hands on deck, and we start the implementation side of things, right? So there's two branches that take off here. One of them is the code side, which is above, and we'll talk about the art side in a sec. But basically, we'll start here to plan, design, and architect. How are we gonna do this? All right, what systems are we gonna use? What architecture are we gonna follow? From then, as coders, we would go and implement the solution, making sure that our systems are optimal and reusable and extendable, and making sure that it's just well designed. And then that would begin. Then we would go into code review and iteration, right? Where together with our leads, we would go through and make sure that the systems that we've created, these changes that we've made, follow the set standards that we have. Now that's just on the code side. On the art side, again, I'm no artist, but at a high level, I can tell you that it all begins with concept art, right? So you go through, and our talented artists would go through and see, okay, how does this look like in different lighting, in different environments, beside other features that have already been created. And then again, this is an iterative process in itself. And from there, once we know where we're going, very similar to the code side, now that's when we start 3D modeling, rigging, animating, VFX, not to mention sound and all these other things. And finally, once these two stems are done, we can put everything together, right? But we're not done yet. Then it's the QA side of things, right? Where we begin to identify bugs and issues, test edge cases, like what happens if I unplug my network cable halfway through this level, right? And then we address these issues and fix the bugs, right? And again, this is an iterative process. But then hopefully, after we've done this, our feature is complete. And after that, we've added value to our product. Or have we? So, what happens if after all of this we realize this isn't really what we were hoping for? Maybe it doesn't quite address the need that we had at the start. Maybe it does address it, but only partially, and unless subsidized with something else, it doesn't really fully meet our needs. Sometimes it could have even solved the need, but created another issue altogether. So what do we do now? Well, if we look at how we got here, we could potentially be in a lot of trouble, right? You see, we involved so many people, so many different disciplines, so many hours of work, and now we have something that we need to drastically change, if not scrap altogether. So how do we get our time back? Well, we can't. This was simply an inefficient use of our time and resources. But the more important question today is, why did this happen in the first place? And the answer lies right here. As you can see, there was iteration all throughout our workflow at the QA level, at the art level, at the code level. But at no point in our workflow did we actually stop to have a think and to test if our hypothesis was really true, if our solution really addressed the need that we had. And so this is the issue that rapid prototyping tries to mitigate, if not completely resolve, right? And by adapting and innovating on what our typical development workflow would look like, and essentially splitting it up into two different phases with two very different goals, we can create a system where you can try before you buy, where you can test the waters before you dive in head first. And so, in phase one, our motto is to fail fast in order to succeed sooner. In this phase of the prototype, there is no guarantee that what you're doing, that this idea, this concept that you're working on is successfully going to address your needs. And so our focus has shifted a little bit. In this phase of the prototype, our goal is to gather as much information as possible in the least amount of time. Evaluate the idea itself, not the feature. That is, address the hypothesis first. And at the same time, spend as little resources and involve the least amount of people as possible. Phase one is all about the idea. And we're striving to answer two very important questions. Does our idea work, and does it add value? And if at any point the answer to these questions is no, we go back to the idea and we iterate on that before we've involved anyone else, before we put any art into it, any sound, and even a lot of the thought that we put into our coding. Now, at this point, whether our idea becomes something solid that we want to invest in or is entirely thrown away, that's okay. We haven't lost a lot, right? So let's revisit our workflow diagram now with the rapid prototyping involved. What does this look like? Well, pretty much the same at the start, right? We identify a need, we brainstorm solutions. Excuse the font again, guys, sorry about that. We set a hypothesis, we write a spec document, but it's as we move to the implementation phase that things start to change a little bit. So we review and understand our tasks, and where we would normally come in, plan, design, and architect our solutions, we are no longer going to do that. We're going to stray away from that because our goals as developers in this time is to to implement a solution as quickly as we can, to hand something back to our designers as quickly as possible, so they can play, test, and evaluate. Evaluate what? Well, first of all, is our need addressed? So we come to this fork in the road. If the answer is yes, we can proceed to phase two. If the answer is no, then we got to ask ourselves, okay, well, is it because minor adjustments are needed? And if the answer is yes, okay, sweet. We just go through again, brainstorm what we need to change, how we can adjust this, and go through again. And if the answer is no, well, then the prototype is scrapped. And as you can see, we've done really well to create this green iteration cycle very early into our development pipeline, right? And as programmers, as developers, we have an incredible amount of influence in this phase around the efficiency that is involved, right? This green cycle you see here is bound to happen, right? But if we have to, as developers, can decrease how long it takes to do a single cycle of this, and or decrease the total number of cycles that are needed before we come to one of these conclusions, basically, we can drastically reduce the amount of time we remain in this phase. So how do we do that as developers? What can we do to decrease the cycle time and reduce the amount of cycles? Well, there's a few things. First of all is the concept of gray boxing. So as many of you might know, or some might not, gray boxing is basically the idea that we should not focus on any of the looks or any of the visual stuff, solely focus on the functionality, right? So don't worry about making it pretty. Don't worry about making it look nice. No animations. Spheres and cubes are your friends in this time, right? Make it look janky, but that's okay because we're just testing the functionality. The second one is to have a design-like mentality. Now, by that I mean is as developers, as we're building our feature, right, we should have in mind what things our designers might want to change, modify, and tweak throughout the whole throughout this feature, right? So that way we can leverage our editor and our game engine's editor and serialization utilities so that we can expose that. What we're trying to do here basically is code ourselves out of more work. Because the last thing you want is that you've got a feature, something moving on the screen, and you've hard coded the speed, right? And then your designers come in, they're like, I want to make it faster, and you're like, I gotta stop what I'm doing, and I gotta go back, and I gotta go change my hard code value. We don't need to do that because we can leverage our, for example, Unity and Unreal is the same. You can expose those to the editor, empower and equip your designers to make those changes for you. And the last but most important thing that you can do as a developer in this phase of the prototyping stage, and I can't believe I'm about to say this, but it's to write trash code. Yep, you heard it here. I got it out of my chest. Now you're probably sitting here and you're like, I'm at a game developers conference in a programming stream, and this kid is telling me to write trash code. And after hearing some of that, I completely understand if you feel a little bit outraged. Right? You might be a little confused. Or perhaps you just want to jump ship and get out of here as quickly as you can. But before you get out of your seat and run out of that door, hear me out, right? There is a time to think about the code that we're writing. And that time is almost all the time, except right now. So what does it actually mean to write trash code? Right? How do we write trash code well? Right? Well, when I say to write trash code, what I'm referring to is that we need to change and adapt our mindsets to no longer invest time and in planning and designing an architecturally sound solution. Nor should we be thinking about the performance or the optimization of our systems. Nor are we considering, how our new features, mesh with other systems in our games. Right? We've been trained throughout our careers, right, to do these things. And don't get me wrong, all these things are crucial, but the time to think about these things is not now. Writing good code takes time, and remember, at this stage of the prototype, we don't know if this is going to end up in the bin. But we're game developers, right? So enough of me talking and you guys imagining what this could look like, and let's actually think about a real-life example, right? So let me set the scene for you, right? We have a game here. We've been working on this for a wee while. It's a game where you as the player are stranded on an uncharted, undiscovered island, right? Ooh, cool, right? Now, on this island, you can explore. You can craft weapons to defend yourself from the wildlife and also from the unpredictable natives on the island. And our designers on our team said, you know what, we need to revisit this whole weapon thing, right? Instead of just being able to craft weapons, maybe we could just also allow weapons to spawn randomly on the island, right? And that way it encourages exploration and a bit more randomness in our levels. And you know what? Something else? We also want the natives, which are basically bots, right, running around the island, to be able to find these weapons and use them on you if they're hostile, right? Okay. And then they'll go ahead and they'll write their spec document. So we'll see. Okay, here you go. This is a very basic version of it, but we want randomly spawned weapons on the map every 15 seconds. Cool. Weapons cannot spawn on top of like rock or boulders or whatever, or any obstacles on the map. Maximum of 5 weapons spawned per level, and they can't be spawned within 10 units of the shoreline. And natives can now use weapons. So we got our spec, and so let's go through together and create something that we could quickly so that we can hand it back to our designers. So let's start with the weapon spawn system, right? Well, the first thing we can note is these variables, as I said, exposing our serialized fields, right? So immediately I can see, okay, 15 seconds, they might want to change that. 5 weapons, they could change that later. 10 units from the shoreline. I can't trust that these things are set in stone. So immediately I expose them in Unity, for example, and allow them to change it if they want to, right? But moving on to the implementation side of things, and again, I'm not going to think too much about this. I'm just going to start a coroutine where I'm going to loop through and do something until I've spawned a max amount of weapons. And again, sorry about the formatting there, team, but we'll get through it, no worries. What are we going to do? What are we going to do each loop? Well, we're going to wait the spawn rate, so 15 seconds, and then we're going to get a valid spawn position and spawn a weapon there, right? So how do we get the spawn position? Well, first of all, we can get a random coordinate inside a unit circle, which is basically rolling a number between -1 and 1 twice, so 1 for your x-axis and 1 for your y-axis, and then multiplying it by the spawn radius, right? From there, we'll get once we calculate what the world position of that is, we'll get a point right above and right below, and then we'll do a raycast from the top to the bottom to see if we collide with any rocks, and if so, then we just repeat this, right? Until we have a valid spawn position. So that looks pretty good, right? We just chuck a weapon spawner in our level, make sure that it's all configured and the variables are all set up, and we're good. Awesome. I'm not going to think about it too much, and that should work, and we move on, right? So onto the other problem, which is, okay, now we need to make our natives, which are basically units, other types of units, use weapons. So let's look at the code that we already have. So a unit is just an abstract class, and not much in it. It's got a movement speed, so we're basically saying all units have a movement speed. That means they can move. A player unit is also a unit, so it can move, but it also has a name, a mouse world position, which is where they're aiming, right? A damage multiplier, and a current weapon. And in the update loop, basically we're just going update the mouse position, calculate any damage multipliers, and if they press the space key, then we can fire the weapon if they have one, right? Now, let's have a look at the weapon class and that fire function. Well, nothing super complicated here. Just a weapon, got some base damage, and basically what we're doing is we calculate our total damage by multiplying our base damage by the player's damage multiplier, and we need to calculate our fire direction by taking the player's position minus, sorry, where the player's aiming minus the player's position, and then we just fire a projectile, and then we log, hey, this weapon has been fired by this person with a total damage of this, right? No, not too bad. So we need to modify our weapon class. So today we're not going to focus on the AI of like when should the native fire the weapon or anything. I want us to focus on the weapon class and how we would need to change this to accommodate our new requirements, right? So to do that, the first thing we've got to do is change the signature of our function, right? So assuming that we have player units and now a native unit, right? And now we need to change our signature to accept the base class of them both, because we don't know if it's a player or a native now. And that means that we also need to check, what is this thing that is firing us, right? So we try to get it as a player, and we try to get it as a native. And if it's neither a player or a native, we say, hey, I don't know what you passed in here, but this is not something that can use a weapon, and we return. But then, because now we don't know what we have, we might have to modify our code a little bit and say, well, actually natives don't have a damage multiplier, so if it's a player, only if it's a player, multiply the base damage by the damage multiplier. If not, just use the base damage. Okay. And then you're going to calculate the fire direction, which again depends on what type of unit you have. If it's a player, it's a mouse world position, right? But if it's a native, you got to find wherever the bot is aiming, which is something entirely different. And again, we fire the projectile, and even to finally log what we had before, we need to see, well, player has a name, but the native won't have a name field. It'll probably have some bot ID or something like that. And so, yeah, but there we go. That works, right? And so we're good. I'm not going to think about it too much, and that's fine. And we're moving on. And having done this, we've met all the specified requirements, and I think our designers can start playing it and answer those two questions. Does it work, and does it add value? Now, at this point, two things can happen, as I said earlier. Design could decide that this idea is not really working. It's not really what we had in mind. It's not really achieving the goals that we had planned. And if that's the case, then we just throw it in the trash, right? Or design can say, hey, you know what? This is actually really good. It's exactly what we needed. Let's go ahead with this. And if that's the case, well, we actually do the exact same thing. We throw it in the trash. That's right. You finally come together and you've iterated through and worked on this thing to get it where it is today. You've poured your blood, sweat, and tears into it. And now, once it's all working as you needed, you have to dump it. Now, understand that can be a very counterintuitive thing to hear. Why? Now it's working, right? But if you've been following me so far, you understand that to get here, we had to write trash code. And what do we do with trash? Well, we got to get rid of it, right? So this brings us to phase 2 of the rapid prototyping phase, I guess, which is the rethink, the redesign, and the re-implement stage, right? It is at this point, what was before hovering as a question mark now is solid, and now, and only now, is the time where we should invest a significant amount of time, thought, and energy into the feature, right? Now's the time that we can involve other disciplines in, bring our artists in, bring our sound guys, and we start working on this. And for all us developers, now is the time where we need to deal with our mess and scrap our original implementation and completely rebuild from the ground up. So as our focus shifts away from simply making it work, what are the things that we need to be thinking about? And what are the new goals as we look to transfer our prototype into a production feature, right? Well, the first thing is performance improvements, right? So in phase 1, we solved the problem, but we didn't necessarily solve it in the most efficient way. So now is the time to go through and do that, right? Second of all is making sure that our systems are reusable and extendable. And by that I mean, making systems that don't just work for one case, but actually can be reused for our code base in multiple places, or even in multiple code bases as well. And extendable as in you can build on top of it without having to refactor or rewrite the system entirely, right? Now is the time to think about good design and architecture, right? So what design principles are we following? How are we going to architect this? How does this fit in? Which brings us into the next point, which is code-based cohesiveness, which is basically it's not just about how good your system is or how well it works, but also how does it mesh with other systems already existing on your project, right? Now, but we have 2 examples of this, so instead of just going briefly over it, we can actually dive into the things that we've already done and have a look at the goods and the bads of what we've already come up with for those 2 examples. Now, before I do jump onto that, I just wanted to say that this, by no means am I saying these are the correct solutions, right? What I want you to, I guess I want to draw your attention to is how many things we can oversee when we're just writing trash code, right? And when we're not thinking too much about what we're actually doing it. Which is fine because we're in phase 1, but now we need to start over. So, starting with our random weapon spawning solution, our early approach was to roll a random number between -1 and 1, right? Both in the X and the Y. And then multiply that by our radius. Then repeat this until we finally, over and over, until we finally have a coordinate that's valid. But while this works, even at a quick glance, there are some big red flags in that code. The first issue is our granularity, right? So getting a random number between -1 and 1. How many numbers are there between -1 and 1? Some would say 3, right? -1, 0, and 1. Well, depending on what you're using to get this random number, for example, Unity's random, right? You could get one roll of the dice, it's 0.3, and then you roll the dice again and you get 0.30002. And those are 2 very valid numbers from a random number generator, and they're both valid faces of the dice, right? And the problem is, when you translate that into coordinates on our island, that's pretty much that's visually the same coordinate, right? If you spawn something at 0.3 or at 0.30002, you're not going to tell the difference, right? And so, even though technically every point on our island is valid, what starts happening is what you find interesting is as you start plotting where things spawn, at first it's quite normal, quite random, but as you keep plotting more and more things, what you start finding is that you run into these clusters, which you can see here in orange, which are very tightly packed, and you also run into these areas which are completely empty, right? And this is probably not what we're wanting. This is probably not what design wants, and it's not what we're expecting. And we lose a lot of coverage when we get points that are so tightly packed. Not to mention the ones that are literally on top of each other that you can't even tell are there. But it becomes an even bigger issue when we look at the next problem. So now that we've seen that it's very possible to roll the same or very close to the same number, what would happen in our current implementation if we got really, really unlucky and we rolled on top of a wall, on top of a rock, and then we did it again and again and again, and we're getting really unlucky? How many times do we need to find a spot? Well, not only does every time we fail to find a valid spot, we need to do another raycast, which is generally quite expensive, right? But actually, with our current implementation, if you remember, we just did a while loop, which means until we find a valid spot, our program hangs. It just sits there and it's frozen. And you could say, I know some of you are here, okay, David, but like, what are the chances of that happening, right? Maybe after 10 attempts and it's so quick. And you're right, but that doesn't give us an excuse to push it aside, right? What if tomorrow our designers are like, well, let's double the amount of rocks, right? Okay, now there's more chances of you failing, right? And then the week after, maybe they're like, oh, also we don't want it to spawn on top of trees either. Now you have a very small area where you can find valid spawns, and most of the time, your valid spawn finder is going to fail, right? So as good coders, we can't rely on luck or lack thereof for correct execution of our programs. And so we need to think, if it can happen, it probably will happen, right? So we really need to think about how we do this again. And that's why I said we need to scrap our original implementation. We don't want to glue it together or duct tape it back. No, we want to start over and rebuild on the foundations, right? So what if instead, and I just want to go through like some of the thinking that you can have, right? So again, this is not necessarily the solution, but think about like, what if we didn't roll a number between -1 and 1? What if instead we could define the granularity ourselves and divide our map into sections, right? And that way we can control the coverage of our map, right? And once we have equal size sections, right, and we can collect all the possible coordinates on this cross section, right? And then we could build a list of every coordinate on the map. And now, instead of rolling a number between -1 and 1, right, you could just roll a number from 0 to the size of your list of points, right? And now, even though you're still rolling a random coordinate, it's more evenly spread throughout your island, right? So you got a wider coverage. And this is good. This is a step in the right direction. But can we do better, right? One thing that I can see from seeing this as well, actually, the rocks are static. Do I really need to brute force my way into finding which spots are valid and which aren't? Maybe I can create a an inspector or editor tool where my designers can come in and single-handedly pick which points are valid and which are not. Something that could look like this, right? And now we've gone from now we have a collection of only valid points, right? And so we've gone from what we had a brute force, runtime, expensive algorithm which would raycast over and over to now something that is at edit time, so it gets baked in, right? It doesn't happen during your player's session, and on top of that, you also have more control, right? Because your designers might say, you know what, I want this whole area to be free of spawns, and so you're giving them more control whilst also creating a cheaper algorithm. And so these are the sort of things that I want you to think about during this time. So now let's look at our other example, which is the natives, right? So let's just go back to the code. There we go. There we go. Nice. So this is the code we had before, right? This is what we had to do to make sure that our native units could fire weapons, right? We not only had to change the signature, we had to add a whole bunch of conditional checks. Now, what's wrong with this code? Well, I think at first glance, my first question would be, why does my weapon need to know who's firing it for it to function correctly? Like, those are two very different things. The weapon shouldn't know about the user, right? Like, it's quite weird. And on top of that, you see, good code design ensures that systems work cohesively and that changes don't propagate throughout the code base. And what we have with the solution that we have here, if tomorrow we added a third unit that could also use weapons, we would have to add an additional check at every level to see, okay, now we're going to check this, and now we're going to check that, and very quickly, our weapon class is going to bloat and bloat and bloat and become a hot, tangled mess, right? So we need to really rethink how we do this. So again, let's think through it. Let's go together. And what's the first thing that comes to mind? Okay, maybe we put those conditional things like the identifier, the target position, and the damage multiplier in the unit class, right? And that way, much cleaner in our fire method because we don't have to check there. Like, we just call the method and we expect that whatever those methods return is valid. Okay, much better. Our weapon class is now back to that's normal size, and if we add more units, it's all good. They just implement those methods, and we're fine. So that's all good. And that's, again, step in the right direction. But what happens if now, or tomorrow, we have units which can't use weapons, right? Like wildlife or NPCs, right, in your island. Are you going to force anything that's a unit to have a target position and a damage multiplier when they can't use weapons? It's a bit strange, right? Even if we make those methods return nothing or do nothing, right? You should never have functionality or functions in the blueprints of your objects which don't apply to that object. So having a get target position in a wildlife class makes no logical sense. So even though it's a step in the right direction, this is not the solution. So you might say, okay, well, why don't we go one step further and make an attack unit, which extends from unit, right? And then player unit and native unit can extend attack unit, and then everything that can't attack or that can't use a weapon can just extend from unit. Okay, now we're looking better, right? Because now we can just say, okay, our weapons fire has to take an attack unit because we know that anything that's an attack unit has those methods in it. But then we also, and again, a step in the right direction, but we also run into another issue now, which is now we're saying that only attack units can fire weapons. And while this might be true today in our project, what if tomorrow something changes that makes it that that's no longer valid? What if tomorrow designers want to add a booby trap into the island, right, which fires a weapon? But a booby trap is not a unit, because we said a unit has a movement speed, and that doesn't make sense, or a turret, or think of it of whatever you like, right? Now we're in trouble, and now we're going to have to refactor everything again because, oh my goodness, what happened? And so we need, again, another solution. And so I hope that I'm kind of working through it with you, right, about the thought process that goes into it. So maybe we need another type of solution, something in between, right? And what first comes to mind is an interface, right? All right, so we make an iAttacker interface, which is basically a contract that says anything that's an iAttacker has these properties, right? And with that, we can say, okay, great. So now our player can be an iAttacker, so it can fire a weapon. Our native is an iAttacker. And tomorrow, a booby trap, which has nothing to do with a unit, can also be an iAttacker. And so, yeah, I just wanted to draw your attention to how it's often not the first thing that comes to mind that is the right solution. And as you think more in the future, yeah, I encourage you to think more in the future, right? So you can start thinking, okay, maybe this solution might work today, but if tomorrow something changes, I'm going to have to refactor the system again. And we should be aiming to code in a way where, as I said earlier, we code ourselves out of more work in the future, right? So apart from this, phase 2 is exactly what we already looked at in our original prototyping workflow. Except that now, right, not only you, but the rest of your team have the confidence in knowing that at the end of this massive workflow, you're going to have some value, right? You're going to have some tangible value added to your product instead of, oh, maybe this didn't work. So as I finish off, I just wanted to talk about one last thing, and it is how we should leverage version control when we're doing things like rapid prototyping, right? It's quite common that while we're working on our projects, we have both, if we're working on the same environment, let's say that I'm working on this weapon spawn system and I'm prototyping it. If I'm working on the same environment as everyone else in my project, I risk a few things, right? First of all, someone might run into my code and be like, oh, this is nasty. I gotta fix this ASAP, right? Where you're like, oh, I wrote this to be bad code. I don't want anyone changing it. This is purposely bad. So we don't want that. We also risk people building around or on top of our bad code, right? And then later on, you have to, if say this feature gets canceled and you got to now strip it out of your code base, now you also got to fix whatever else someone's wrote because they were leveraging your system, which now is gone. So you get so tangled up. And in general, you also just muddy the waters in your code base between what's there to stay and what's kind of hovering around as a question mark. So we don't want that, right? So we want to make sure that we protect our prototype from changes in our project, and vice versa as well. We want to make sure that we protect our project from the hacky code on our prototype. And we do that using version control. So in Git, right, it would look like simply making a branch of your master branch And this solves all the issues that we just talked about, right? Your changes are in your prototype branch, everyone else's changes are in master. When you're ready, when the feature has been approved, when it's all good to go, then you can merge it and you're good. Sometimes though, you run into a scenario where you need to prototype multiple things at once, right? You have multiple teams, small teams working on different features at the same time. And in that scenario, well, you do the same thing, right? We just create an individual prototype branch for each feature. But you also run into a situation where your designers want to test all the features or some of the features at the same time. So to do this, what we want to do is basically create a generic prototype branch where we can merge some or all the features that we want tested into. Now, in doing so, this generic prototype branch basically becomes a testing environment for your designers. But at the same time, it becomes a one-way branch, as I like to call it, which means it can be merged into, but never out. And the reason why I say that is, first of all, it has one or more features which are not approved, which have hacky code, so you don't want those spreading around your code base, right? And two, when I merge two features together into generic prototype, I'm probably gonna hack my way through, merge conflicts and things like that. I just kind of want to make it work. I'm not caring too much about how this feature interacts with this feature too much because it's all prototypes, right? And so basically you do all your changes, any adjustments that you need on your prototype get done on the individual prototype branch and then merged up to the generic prototype if you need. And once that's complete, then you can finally just merge your specific branch back into master, right? Now, this does bring us to a couple of questions, this multiple prototype branch things, and having a separation of our team, right? We have one or two coders on each branch doing a separate feature. How do we ensure that there's still collaboration between these three coders, for example, right? How do we know that despite them working on different things, they're adhering to the same design principles? They are solving, not reinventing the wheel each time. How do we know that they're using the consistent architecture throughout? See, there's a very common perception in our industry that every one of our coders needs to be a leader, right? They need to be an excellent collaborator, or at very least, a good communicator. And in a perfect world, this would be ideal. Don't get me wrong, that's awesome. But it's not really the case in real life. As we look around us, not every great coder is a great leader. Not every genius programmer is an amazing communicator. And that's okay, because we don't need to expect that from them, simply because we don't need to. What are you saying, David, that we don't need, great leaders in our teams that are going to enhance our team collaboration and encourage knowledge sharing within our discipline? No, we definitely do need that. But what I'm saying is that I believe the responsibility shouldn't be on any one of these individuals, but and the responsibility shouldn't lie across the whole team as such, but rather on the shoulders of one or two individuals, which are your code leads. You see, so what are our code leads, right? Are they good developers? Yeah, normally they are. But there's good coders, as we said before, there's good coders who aren't code leads, right? Are they really experienced seniors? Sometimes as well, but not necessarily. There's a lot of very experienced people who don't lead, right? So what are our code leads? Well, code leads are the glue that holds our team together, right? That catalyze the team collaboration. As we saw earlier, maybe these three people don't interact with one another. You can't expect them to, right? You can't expect this person to talk to the person working on that prototype and be like, hey, what systems are you using? Sometimes that happens, but it's rarely the case, right? You're working on your own thing. However, the code lead has oversight over each one of these branches and each one of these teams, right? When it comes to code reviewing, the code lead's the one who's been exposed to the pros and cons and the solutions that each person has implemented, and therefore is the one who is equipped to advise and to guide the rest of your team, as well as to encourage solutions and designs and architectures, right? It's like if each one of these individuals were working on a specific part of the puzzle, but it's the code lead who has all the puzzles in front of them, right? And so they're the ones who are equipped to do that. They're the ones who have the ability to identify where there's been a duplication of logic, like you and you solve the same problem. Let's not reinvent the wheel, right? Or yeah, oh, you know, this person solved this problem like this. Maybe we should use the same solution, and so on. And they're also the ones who can ask the right questions, you know, and can guide you and say, hey, you know, have you thought about how this person answered it? Maybe that's a very good thing to look into. So guys, as I wrap up, we'll just run through. Yeah, so it's your code leads who need to have the leadership, the collaboration, the communication. That's very important. And so to wrap it all up, guys, try before you buy, right? Ensure your idea is solid, solves the issues that you're facing, adds value to your overall product before you dive in head first. Adapt your workflow, right? So to achieve this, add an iteration cycle really early into your development pipeline, right? Where you put your hypothesis to the test. Hypothesis, that's a very hard word to say. Optimize your iteration cycles, right? So strive to be as efficient as possible by using techniques like gray boxing, design-like mentality, and of course, as you all know, writing trash code. But write trash code well, right? So while the idea has not been approved, don't think about optimization, design, architecture, project cohesiveness, extendable systems. Don't think about that at this time. But once it is approved, then please, 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 it is crucial to go back and clean up your mess, right? Scrap the code that you had before and prepare for a clean re-implementation of what you had, and think about how you can better solve the problem. And finally, leverage your code leads. Working on isolated features doesn't mean that we need to compromise on collaboration or knowledge sharing if we can really lean on our code leads to do that. And so guys, with that, that is rapid prototyping. And I hope that you can use that whether you are an indie developer, whether you are in a large production studio. Use it to save yourself time. Use it as your safety net. And use it to dip your toes in before you dive in head first. So yeah, thank you very much. Do we have time for questions, bro? Yeah, we got it. Cool. Maybe this one? This one's working, I think.
Okay. Does anybody have any questions?
I can repeat the question. Yep. Yeah, it's a good question. Can I go back? The answer is you can. It depends how, it's more of a personal preference thing. You can completely start a new branch, for example, as you say, trash it, and just go, you know, prototype, weapon spawner v2, or like remade. It doesn't matter. I mean, I've worked in places where we've done both, right? So, sorry, going back. Yeah. So I think the question was, why even do this, right? Why even merge it back? Why not just, since we're going to scrap this, let's just create a new branch and start again? Totally. I mean, I think that's very fair. You can do that. There's no reason why you wouldn't do that. It depends also. I think as you got to evaluate how bad your original implementation was. So if it's like a complete rewrite, for sure. Sometimes it's not as drastic as we saw today, where we like, you know, sometimes it's just adjusting things. Though I do encourage you to really rethink the solution. Sometimes it's not as drastic, the changes that you have to make, and in that case, it might be fine as long as your code lead is going through and reviewing that what you've done in this branch is good, then merge that back. But yeah. Hey, bro.
When you're starting a new project, some of the decisions you make at that point can have drastic consequences, you know, months, years down the line.
Yes, sir.
How do you make sure that you don't lock yourself into a bad coding framework when you're starting something new? This makes a lot of sense when you're adding new features and it already exists, but when it's greenfields, how do you make sure that you don't break everything?
Yes, that's a great question. It is really hard. I've been on projects which have done it really well, and projects who have done it really badly, right? I think it's all comes down to the ability for those key people in your teams, like your code leads, but also your design leads, right, to look into the future, right? If you can, if your design team can communicate really well in advance what they think their game's gonna look like, it really empowers, because sometimes the issue can be like your code lead didn't plan well, right? But sometimes they planned well with the information that they had, and now the project's come so different to what it originally started as, that yeah, we need to, the architectures don't really fit anymore, right? So I think the best thing you can do is really ask your designers to give you as much information as possible, to really give you as much accurate information so that you can really, your code leads can really make a sound design from the ground up. But sometimes, as you said, that might not happen. The game changes, and yeah, you just at that point have to say, okay, do we think about rewriting systems, doing a big refactor, or do we just, tackle our way through it? But that's all the time we have, guys. Thank you so much for being here. If you have any questions about what you heard today, we'll be around the conference. There's also a group of us from Mytona. Wave, guys. That's it. So if you have any questions about us, come say hello. Not all of us bite, some of us do, but just be careful. You'll kind of see it. Alternatively, you can reach me at my email, daviddelgado@mytona.com, or just go to our website. And yeah, thank you so much. We'll see you around the conference. Come say hello. Yeah, be friendly. Awesome. Thank you, guys.